from my position. Lunchbox.
In this video, you're going to learn about how to solve polynomial equations using the remainder and factor theorems. We are going to use November 2011 paper 1 ZIMSEC for illustration. The question reads, the cubic polynomial f of x is given by f of x is equal to 2x to the 3 plus 6x squared plus kx plus 12, where k is a constant. Here, the function f of x leaves a remainder of 6 when divided by x plus 2. Find a, the value of k, 2 marks. B, the solutions of the equation f of x is equal to 9. Given that it has only one real root. So the question is saying we have to find the solutions. But the equation has only one real solution, one real root, or one real solution. It's one and the same thing, okay? So what is the question saying? Find all the solutions. Find the solutions, but there is only one real solution. So this means you have to find the real solution and also other solutions that are not real, which means they are complex solutions. So now we look at part A. So in this case, we are going to apply the remainder theorem. The remainder theorem states that if f of x leaves a remainder of 6 when divided by x plus 2, then f of minus 2 is equal to the remainder. That's the remainder theorem. So what does this mean? This means that since our function leaves a remainder of 6 when divided by x plus 2, we are going to substitute minus 2 for x here, minus 2 for x there. And what do we get? So we get 2 multiplied by minus 2 to the 3 plus 6 multiplied by minus 2 to the 2 plus k times minus 2 plus 12 is equal to 6. Then minus 16 is what we get here, plus 24 minus 2k plus 12 is equal to 6. Then we group like terms and we simplify. We get k is equal to 7, which is our answer for part A. You get your 2 marks there. So after getting k is equal to 7 here, we move on to part B. We are given that on part B, f of x is equal to 9. 2x to the 3 plus 6x squared plus kx plus 12 is equal to 9. So this is our f of x, right? So f of x, this is f of x is equal to 9. But we have calculated the value of k and it's 7. So we're going to substitute this 7 for k here. And what do we get? We get 2x cubed plus 6x squared plus 7x plus 12 is equal to 9. Then we bring all terms to one side and we simplify. We get this expression. Now, this, if you check, is a cubic polynomial, is a cubic equation. So in order to solve a cubic equation, we make use of factorization. And that factorization is done by using the factor theorem first. So we need to find the first factor using what we call trial and error method. That is the factor with the root which gives 0 if we substitute it in f of x. So we try, let's try -1 here, f of -1. If we substitute -1 here, this is trial and error, right? We want to see if it gives us 0. If we substitute -1 here, and here, and here, we get -2 plus 6 minus 7 plus 3, which gives us 0. Therefore, since we had substituted -1, the factor is x plus 1. You need to take note of that. That is, if you substitute +1, then the factor will be x minus 1, okay? So after finding your factor, you now use long division to find the other factors, or to find the quadratic factor specifically, this quadratic factor here. So using long division, what you do, you divide the first term here, the first term on your divisor here, which is x. You divide it into 2x cubed, and you get 2x squared, right? Then after that, you say 2x squared multiplied by x. You get 2x to the 3 here. Then you say 2x squared multiplied by 1 here. You get 2x squared, right? Then you subtract this from this expression here, from our polynomial here. So you subtract 2x cubed minus 2x cubed. You get 0 here. So there is no need to write it. Then 6x squared minus 2x squared. So like will subtract like, right? And you get 4x squared. Then you drop this 7, you drop this 3, since there are no like terms down there, okay? Then after subtracting here, you repeat the same process. You divide 4x squared by x, and you get 4x. Then after that, 4x times 4x here times x, you get 4x squared. 4x here times 1, you get 4x. Then you subtract this from this term here. And what do you get? You get 0 here, and you get 3x here, and you drop down this 3 here. Then after that, you repeat the same process. X into 3x, you get 3. 3 times x, what do you get? You get 3x. 3 times 1, you get 3. Then if you subtract this from this, you get 0. Therefore, this expression inside here is the same as x plus 1 multiplied by this quotient here. This is the dividend. The dividend is the same as the divisor times the what? The quotient. Okay. Now, you have this expression here inside the long division. Our dividend here is this expression. It is exactly the same as x plus 1 multiplied by 2x squared plus 4x plus 3. The expression right here times this one, that's what we did here, is equal to 0. So we're going to solve this. It's better to solve this. It's simpler because it's factorized. So x plus 1 is equal to 0, or this quadratic expression is equal to what? To 0. So we now come here. Either x plus 1 is equal to 0, so x is equal to minus 1, or the quadratic equation, this quadratic equation, you remember this quadratic equation is the one here, this one, or the one here. So that quadratic equation is equal to 0 also, since it's factorization. So what you do, you use the quadratic formula. You substitute. Your b is 4, your a is 2, your c is 3. You substitute here, you work out, you simplify. What you will get is minus 2 plus or minus root 2 plus or minus root minus 2 all over 2. And if you check, if we solve it here, you will find out that you remain with the negative inside the square root. If you punch that in your scientific calculator, it will give you error 2. So there is no square root of negative 2 when we are in real numbers, when dealing with real numbers. But since we want to find all the solutions, we have to include these solutions too. Okay? So we need to find all the solutions. Therefore, we apply complex numbers. For complex numbers, negative is equal to I squared. Negative 1 is the same as I squared. So instead of writing root negative 2, we write root 2 I squared. Or negative 2 negative root 2I squared over 2. Right here. So this is what we are doing at this stage. Therefore, we remain with minus 1 plus root of 2I squared. It's root 2I outside the square root because root I squared is I. Just because the square root and the squared cancel out. So this is, we got this, or the other solutions just in a similar way. You replace the negative sign by I squared, then you get I, since root I squared is equal to I. So I will be outside the square root. Okay?